appetizer to trap your guest, a cheesy main entree, and a sweet mouse-tastic dessert to finish it off. It's a meal on wheels. First, our mousetrap appetizer of the general design. You'll need a physics student to get started. This mousetrap car is designed to be lightweight and to travel a great distance. To achieve a perfect distance, traction with the ground will be needed. The front wheels of the car are left alone to allow it to accelerate smoothly with little friction. On the back, the wings have been placed around the edges to create traction with the ground to get the car rolling without spinning out. Next, there will be two types of friction occurring in this process. The first is between the wheels and the ground. CDs are used because it has a thin edge and smooth surface to allow less friction. Finally, friction is also happening at the axis. Two small points where the body of the car is connected to the axis. The small amount of area of contact is there to reduce friction. Now, once you have finished cooking the appetizer, take it out of the oven and let all that physics information sink in.
Now, time for Newton's main third entree. So, the mousetrap snaps, causing it to unwind and drive the wheels forward, and moving the rest of the car in that direction.
While this is happening, the wheels are experiencing friction with the ground, creating an equal and opposite force with the wheels and car moving forward. Once all that information mixes, slowly add some flour and butter and stir it to combine. Then once that is done, the car is able to move forward, even though there is a friction force acting on it in the opposite direction. Because the car is able to move forward, that means the forward force from the mousetrap car is greater than the friction force, making a positive total force to move in the forward direction. And finally, for the best part, the dessert. Yummy, I can't wait. The first thing you should do is eat a big piece of chocolate. Then, by increasing the length of the lever arm, it increases, which is increasing the amount of work done. As the lever is pulled back, the elastic potential energy is stored in the string, connecting the lever arm to the axle of the wheels, and the spring of the mousetrap.
Then, the car moves and the energy is transferred into kinetic energy. When the mousetrap car slows down, the elastic potential energy and kinetic energy decrease. Not all of the energy is used towards kinetic and potential energy though. The leftover energy is converted into heat energy because of the friction with the ground caused by the wheels, which also causes the car to slow down and stop. With the added length of the lever arm and the greater distance it travels, the time of the force applied increases because it takes longer for the lever arm to snap back to the original position. You have to find the right balance between length of the arm and the force needed to move the car. Work is directly proportional with power, and time is inversely proportional to power, and both go up. And the power of the mousetrap stays the same. Now, cut yourself a tasty piece and enjoy. I hope you had fun learning and how to put your potential kinetic energy to use. Thanks for watching.